First out today, I'm honored to welcome to the stage Ryan Pandya, founder of Perfect Day, the company that is reinventing the way milk is produced industrially. Their animal-free approach is based on safe and proven techniques that give us beer or vegetarian rennet, which will provide consumers and food manufacturers with the same product they already know and love through a more sustainable, healthy, and humane process. And if you didn't already log in, remember Slido and welcome on stage.
Hello, everyone. Can you hear me? Yes. Okay, wonderful. Thank you very much for having me here. It's a pleasure. Excited to share my story with you, and honored to be in front of a room of fellow builders and people trying to make the world a little bit better. My name is Ryan Pandya. I'm one of the founders and CEO at Perfect Day. I have been a chemical engineer for about 10 years and a founder and entrepreneur for about 5 years, and have been lucky to be working with the Horizons team and family for almost as long. So excited to share more. I know that high-level description is probably like very difficult to comprehend, so let me walk you through the story. It's actually not that hard to understand. So basically, we're making the animal-free future of dairy and really helping what is a gigantic, almost trillion-dollar industry globally to really deliver the promise that people have been enjoying for about 10,000 years in a much more future-proof, sustainable, kinder, greener way. And just as a little bit of introduction as to how I got into this business. So my background is, of course, chemical and biological engineering, but it was really with my consumer hat on that I got the idea for what became Perfect Day, because like many people of my probably obviously sort of young demographic, I started off my life eating meat, dairy, eggs, you name it, and really started to look into how my diet was impacting the planet, animals, my body, sort of the whole gamut, and came to realize that there might be benefit to reducing the amount of animal products in my life. And I went vegetarian around 2009, which wasn't terribly difficult. You basically replace all the meat you were eating with dairy and eggs, and it's okay. And then I thought maybe I should try to remove even dairy and eggs, and at that point, replacing dairy and eggs with the current alternatives was really, really difficult for me. And some of you out there might, yeah, I see some nodding, might have had a similar experience. My gut feeling was that there's not going to be progress in this space until someone figures out why these products are not delivering on the promise of dairy. And to me, I wasn't going to look at these things and think, it's magic from cows. It's not magic, it's biology and chemistry, and we can figure out what exactly is making milk milk. And the answer is actually pretty simple to realize. It's the proteins. So I'll walk you through a little bit of how we came to realize that and how we're making these proteins today. So at a high level, here's what we're doing. We're taking dairy into the 21st century by replacing factory farms with breweries. So cows are on vacation, we use fermentation tanks, we can make the real protein found in milk, the most nutritious and versatile protein currently known on planet Earth, in a totally animal-free way using fermentation. And basically, by taking that protein and mixing it with otherwise totally plant-based ingredients, you get milk that can turn into all your favorite products. And that was really important to us, because you don't just want to make yet another sort of single finished consumer product, because that to me isn't an elegant solution to a very large sort of B2B industry. You want to be able to make something that can go through the entire value chain that dairy goes into and perform the same way for the same reasons chemically, and that's what the protein enables. So it's a kinder, greener way to make all the world's favorite foods, or certainly all my favorite foods. So here we are. Let's start with what we love about milk, because honestly, I came into this because I love dairy too much to give it up. So here we go. It's yummy, right? Everyone loves dairy. And even the pickiest kids love milk and cheese and dairy products. And so one of the things I love is that it has this ability to combine with and transform into amazing foods, both sweet and savory. It kind of ends up all over the place. You can eat it all times of day. It's really, really permeated food culture all over the world, and that is part of why it's so important that we figure out a better way to make it. It's nutritious, and actually this is one of my favorite weird little things that you don't often think about. Milk is probably one of the only foods that was really evolved to be digested. It's not a structural part of a plant that we happen to eat, or some part of an animal cell that happens to be nutritious. It's actually meant for babies to digest and turn into energy and building blocks, which is great. And for that reason, it can actually, clinically shown prevent stunted growth and malnutrition, supercharge muscle recovery, and even we heard a little bit about how so much more of the world is reaching an aging population. Similarly, very helpful there, which is fantastic. And finally, my favorite is versatile. Look at that stretch of the cheese. I kind of make fun of almonds here because you really can't do some of these things with current existing sources of plant-based protein. And so that, to me, that was symbolic of what's missing today. Because if you take like soy milk and try to turn it into cheese, the absolute best case scenario is that you end up with tofu, which like, I don't actually hate tofu, but it's not cheese, come on. So these are just a few examples, cappuccinos, melted cheese, the gel of a yogurt, or even the creamy melt of an ice cream. These things are happening because of real functional protein. Here's some things that aren't so great about milk, and I won't go, I'm not gonna hammer too hard on milk, but it is easy to forget how much resource goes into making milk today. This is an aerial shot of a confined animal feeding operation in the United States. So it might be tough to tell, but there's like, I don't know, tens of thousands of little black dots there that are all sort of letting their waste, well, they're not letting it, The humans are making the waste sort of go in the cesspool. It looks like a beautiful green color, but it's not beautiful. It's an algal bloom. It's bad for the local ecosystem in a lot of different ways. Water, land, greenhouse gas emissions, energy, we need to find a better way to make something that demand isn't gonna go away for. It's also a bummer that some people can't enjoy it. So between lactose intolerance, milk protein allergies, it's still I think one of the top 8, maybe even the #1 food allergy in the world. And of course, like me, many, many people out there that are looking to consume alternatives to animal protein. It's a shame that people have to look elsewhere for dairy delight. And finally, some of the other stuff in it. Now, whether or not you think these are necessarily problematic, people are looking for cleaner and kind of more pure sources of food. And so things like lactose, cholesterol, antibiotics, hormones, wouldn't it be nice if you didn't have some of that in your food and we were able to make just the good stuff? That's what we're going about doing here with what I'll call the world's perfect milk. So the idea here is actually really simple. Come with me here for a second. It's this simple. Fermentation is used to make very common food ingredients, and we don't often think about it, but if you want to buy a trainload of vitamin C or citric acid or lysine, where are these coming from? It's all made with fermentation already today. It's just we're using fermentation in the food industry to make things that you and I find kind of boring. Like, I don't think about citric acid, well, I do, but you don't, right? And the idea here is you can actually apply that same thing. It's been used for like half a century to make things that are very interesting and are very important, like proteins that make the core of our food. So since the most important part of milk, industrially and for food, appears to be the protein, why not just make that protein through fermentation? One thing you might not know is that we produce, at least in the United States, we overproduce a lot of cheese just to get to the whey protein. Used to be the exact opposite, right? Whey protein was the byproduct of cheese making. Now we actually make and throw out cheese because people just want so much more protein than you find relative to all the other ingredients. So we can actually just make the stuff we want in a very clean way, better process control, higher density of the cells that are actually doing the biology, instead of having a 2,000-pound animal where only the udder cells are doing the actual biology. Fundamentally, that's what's happening here. And don't worry, I know it's probably a little complicated. I will explain a little bit more in the fireside portion after we light that thing on fire. So super briefly, 3 steps here. We're talking about dairy flora. So the idea here is microflora is sort of this category of life that contains bacteria, yeast, algae, fungi, anything you can't see without a microscope. And all of these things are capable of doing any of the core biology that you find in more complex creatures like animals. So the idea that you feed pure plants to a cow, some magic happens in the animal, and you get milk protein at the other end, right? There's nothing magic about that. It's just biology. So that same thing can happen in much more efficient organisms. So we work with microflora. We empower them with milk's essential genes. What we mean by that is really simple. A gene encodes a protein. So you want the protein, you take the gene and put it in the microflora. It's kind of that simple. There's a lot more to it than that. That gives them the ability to make the same protein cows make. Now we call it dairy flora because it's flora that makes dairy. Simple enough. Put that in a tank, feed it pure plants, and they will convert them, just like a cow would, into proteins like casein and whey, which are the sort of nutritious and functional core of milk. They're nutritionally identical, but they're made from flora. So we call them flora-based protein. The reason that we're not calling them plant-based is because they're not based on plants. They're animal proteins, but they're not made in animals. We've got all these oxymorons that were a lot of needles we're threading in terms of language, and we'll talk about that too. Our protein does everything milk protein does because it is milk protein. And Bessie's off the hook. She's listening to a song called Perfect Day by Lou Reed. Perfect Day model. So here's some of what we can make with milk protein. What we don't show here, and I think is important to stress, is that milk protein goes into many things other than just fresh dairy products. So if you have ever tried to be vegan or eat only plant-based, you would have had the experience of picking up every product in the grocery store and realizing that there's no aisle you're safe. You can find whey or milk solids or milk fat or some part of milk in every part of the grocery store. And again, that's why we're trying to go very far upstream and make all of it. So we've been on a mission to empower the world's biggest brands, the ones who actually move the needle on dairy demand. We're not just here to make yet another consumer brand. We want to actually address where milk is going today. And that means working with the big guys and not being the only ones that get to play with this cool ingredient. So in the world, here we are. The future is actually here. We have done it. So 5 years into our journey, crazy how long it takes to do anything, we actually finally have commercially scaled, gone through regulatory. We are now making metric ton quantities of this protein, and we did the only logical thing. We turned it into a delicious ice cream and shared it with the world. This was a great exercise for our team in terms of sort of maturing us to the point where we can ship a product, you can do something with proper quality control and all these different things, make a package, go through all the exercise required with regulatory to make sure that the language on it is as okay as you can be when you're making something that fundamentally kind of challenges the definitions of some of these ancient things. And we sold out within like 11 hours. Even we didn't make that much, but we thought it would last, a couple days or weeks at least. People were blowing up our website for this stuff. And so Ice Cream Made Perfect, we have a bunch of the obligatory press logos. When people tasted the difference our protein can make, the response was super phenomenal. And we even took an ice cream truck around LA to allow almost 11,000 people to try it. And we have a little video that maybe we have queued up. We've developed a way to make real ice cream, totally animal-free, that's better than you'd ever imagine. And we're here showing people what we mean by that.
We're just trying to start a conversation with people and show them what we've been working on for the past 5.5 years. It's been a crazy ride, and we're finally here. Every single person who's tried it goes, wow, this is really good. I cannot believe it's vegan and not made from real cow's milk.
They've nailed it. It's absolutely incredible. This tastes exactly like ice cream.
We are dairy lovers ourselves, and we didn't want to give up the products we love. So we thought if only there were a way to make milk protein without cows, you could really unlock a better future for dairy. And that's exactly what we've done. We've been able to do that by using fermentation instead of animals to make the same exact proteins found in cow's milk. That allows us to do everything dairy can do. I realized that said the same thing I just said for 10 minutes, so. But it was really fun. And for anyone who's nearing a stage, I don't know the breakdown of everyone's businesses and what you're working on, but huge, huge benefit to actually showing people what you're working on in some kind of minimum viable way, which was fantastic. And finally, we're gonna pat ourselves on the back very, very prematurely and say we've actually figured out, we haven't maybe done it yet and scaled fully yet, but we have figured out the answer here. It's not just to make yet another carrageenan-driven pretend cheese. We're gonna make the real thing. We're gonna figure out a way to make dairy, milk our cow and pet her too, which we thought was cute. So get excited for the future of dairy. Eat the same products you have been, go to the same big multinationals that you have been, and we will help them and help the whole world as kind of one to become kinder and greener. So thank you very much. I think that's all I have, and we'll chat over there. Hello. I was told to give that to you.
Oh, thank you. Hi. Oh, you're there. Good.
Sure.
Thank you for you see who I am? I'm Carolina Sachs. I'm actually from the other part of Norway, which is Sweden, and one of the countries that you try to expand your products into as a first test. We're a little bit stupid, so we like everything that Norway does. Anyway, it's really nice to be here, and I can't say anything else that this is beyond exciting what you're doing.
Thank you.
And we both will be getting questions from the audience, and I have millions of questions, of course. I've been myself working with sustainability and the food sector for many years. So we are really in a paradigm shift here with protein, and we need to eat what's healthy for us and for the planet. And it's really mind-boggling, I think, what you're doing. It's one of the most exciting fields out there right now. Precision biology or flora food that you say is fantastic. creating proteins genetically identical to animal proteins. That's how can you do that, really? And I read a report from Rethinks, and they say that due to precision biology, by 2030, demand for cow products will have fallen by 70%. Before we reach this point, the US cattle industry will be effectively bankrupt. By 2035, demand for cow products will have shrunk by 80 to 90%. And other livestock markets, such as chicken, pig, fish, will follow a similar trajectory. Do you agree?
I don't know if I agree with that. Part of the reason that we're doing what we're doing instead of making another mimicking product is because we don't really agree with that. I mean, to me, I think I get why they want to make these reports. It's very important that we help people see what the future should look like and build a little faith that things can change. But I just don't think it's going to happen overnight. I mean, and that still feels kind of overnight to me. I mean, we interact with the dairy industry, as you can imagine, pretty frequently, and these things take a long, long time to change. So I think to the extent we can imagine that could be true if something like Perfect Day can come along and make something much, much more compelling for consumers. But to me, I wouldn't view that as demand reducing for cows and cow products. I would say it means we found a better way to make them. You see what I mean? I mean, the idea that it would get replaced with the kind of plant-based products we see today to 70% in 10 years, I don't see that happening.
No, I mean it's a vision that's it's
Right.
quite interesting. So do you think that it's a bigger market opportunity for you here than with precision biology than in the plant-based space or the cellular meat space? What do you think?
I do, actually. So
Yeah.
so those are two very different worlds,
Yeah.
we can talk a little bit about. So compared to the plant-based world, I think I made the point several times, there's a real ceiling to the level of quality you can achieve when you're using proteins that are purified from plants. And without getting into too much boring detail,
Be
the reason
careful, Oatly comes from Sweden.
I know, and it's a delightful product, right? And
Just
so here's
kidding.
the thing: like you can make each of these individual. Well, you can make a great fluid milk replacement. Like it'll turn your coffee a lighter shade. It'll go into your cereal and not be water. It'll do these things. But the minute you want cheese or yogurt or ice cream, and I've tried their ice cream. You know, I love Oatly. I don't know if it's like quite what people are looking for to the level of dairy, to the level of being able to replace 70% of the demand, right?
Yeah.
Which is what we're looking for.
Yeah.
So you have to get over that ceiling. To me, protein's the way to do it. So that's plant-based. On the cell-based side,
Cell-based, yeah.
Parimal and I actually came at this. I didn't mention this, but we were doing work on tissue-engineered meat back in 2010 to 2012, and it's very exciting for meat. I don't think it makes as much sense to grow like an udder and get milk out of it. I mean, then you're ending up at the same, like the lactose and cholesterol and hormones are all kind of coming anyway with it, and you have less control. The precision of precision biology, I think, is really cool because without even beginning to do any changes to the protein itself, we can say we're just making one of the pure milk proteins without all the other ones. And just by doing that, for example, we have 40% more branched chain amino acids in the protein. It's more nutritious. It's more functional because it's not being diluted with all the other proteins. So that precision is actually really cool, and you don't really get that as much with cell-based.
No.
And it'll take, I think, a couple decades for that to be scaled up.
Have you experienced any religious or cultural resistance against this product?
Religious? Surprisingly not, actually. Maybe that'll come at some point. Culture resistance, a little bit.
And a little bit adds to, I also have a question around consumers. We saw this movie, you were there, and everybody's happy and
Yeah.
eating ice cream, which I wonder why you didn't bring. By the way, I love ice cream, but how do you really present this to the flora-based is like, oh, what do you mean?
Yeah, we don't hammer that phrase as sort of the first sentence we
Yeah.
say. Okay, I'll talk about that LA activation actually quickly because I think that's a good way to answer this. So the first thing someone hears, like imagine we're on Santa Monica Beach. People are walking by that I would have assumed, no offense to LA, are like the crystal healing alkaline water, side of society. And with these people walking by, we're saying, hey, would you like to try a free sample of ice cream? And we get maybe a third of people or close to it that are saying, no, thank you, I don't want a free sample of ice cream. And we say, well, it's lactose free, it's vegan, it's so good you'd never know. And at that point, like if it was the animals, if it was the lactose, or if it was just a fear that there was nothing novel and I don't want to eat the calories of ice cream for no reason, almost everyone will try it after that, right? And once they try it, it's that simple, right? There's no flora, there's no biology. It's just vegan, lactose-free, but so good you'd never know it. They try it, they love it, now they ask questions. How did you do this, right? I mean, what is different about this? And then we can go a little bit deeper into it. But what I was amazed by is that compared to what I might have seen 5 years ago, there was no one asking about GMOs and being afraid of the core technology we're using. I think the learnings that the industry has had, and we've talked to like the CTO of Monsanto, we've talked to many people who had worked in what I'd call the previous generation of this kind of technology. And the core learnings were you have to be very upfront with consumers that you're using technology and how and why, and that why should actually benefit the consumer. And it's kind of not that mind-blowing when you think about it. But the idea that that you're so far up the value chain, this is what Monsanto said, that you assume the brands will talk to consumers about the technology. They don't, right? It's your job as the technology creator to have that conversation with people. And in our case, what we are making is for consumers. It's compelling for consumers. It's a good reason. It's doing technology the right way for the right reasons. And you know, we have a long, long list of no-no words. Like we don't use the word synthetic. We don't really use the word genetic or engineering, or right? I mean,
Because everybody loves natural,
Yeah.
organic. I mean, that's safe words.
Right.
And then you have all these not safe words.
Yeah, it's a
And
minefield.
some people do call it synthetic. So
Yeah.
what do you answer on that? Is it synthetic?
In
Is
a
it
meaningful
natural?
sense, it's not synthetic. And,
No.
and what I mean by that is, like, if I ask you to imagine a synthetic wood, let's say, like you will picture plastic that's maybe been colored to look like wood or textured to look like wood. We have the mindset that a synthetic product is made out of something else, typically plastic or some kind of petroleum product, and is kind of trying to get as close as it can to fool you. That's not what we're doing here, right? We're making the real thing through the exact same pathway that cows are using. It's just done in a more efficient way. It's just done using fermentation. And everyone's already familiar with fermentation. It's actually got kind of a halo right now,
It's very simple.
having its moment.
Yeah,
Yeah.
it's very good, very simple. And we have questions because one thing that I've been thinking about in this part of the world where we live, we need like 10 to 20% of our daily caloric intake, or around 50 to 70 grams, should be proteins, which we easily get if we eat a blended diet. Are we focusing too much on chasing proteins, that we need to eat so much proteins all the time? And also that when you talked about the whey that comes from cheese, and all of a sudden everybody's eating whey and you build big muscles. You can make proteins very simple now from in fermentation processes. You can make it from CO2. You can make it from grass. So basically you can make proteins from everything, even though they have different kinds of parts. But do you think that we're chasing it too much? And what is the predictions on the cost of protein in the future?
Yeah, okay. Two very good questions in there. So quickly on, are we chasing protein too much? I think in the wealthy Western world, we might be, honestly. It's not the case, I think, that most people, certainly in the bubble I come from, the Bay Area, that people are having medical problems because of a lack of protein in their diet. I don't think that's really an issue. But two things. Number one, you do need a balanced diet. And so the idea that we're asking people to stop eating animal products, go vegan or eat more plant-based, and then everything in that category is primarily starch-driven is problematic to me, right? Or a lot of them are, right? So you end up with, I hate poking fun at products that I believe in, but picture a vegan grilled cheese. You've got two pieces of bread with a starch-driven cheese alternative inside it. It's just carb, 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 which to me isn't really what I feel is the balanced combination of things I want to be eating. And then, of course, outside of these bubbles of wealth and kind of Western culture, there is still a lot of need for protein. And when
There's
we
lack
think about
and stunted children and so forth. Yeah.
exactly. And so globally, no, I don't think we're chasing protein too much. Maybe in some of these pockets we are. Cost of protein.
Cost of protein,
Yeah.
and the cost of your product compared to other products on the market.
So our protein is 3 years ahead of schedule on cost reduction, which is great. I mean, this is the power of how quickly biology is moving. So we're at the point where we can already formulate pretty much every finished good you can think of that's dairy derived, margin positive, at typical prices on shelf, which is great. And as a protein ingredient, that cost is going to come down in the next year and a half to match what you'd find on the commodity market, which is great. And that, importantly, is us in year, 7 at that point, hitting the cost of dairy in year 10,000. And so you can imagine, dairy's at the end of their sort of optimization cycle. There's not much more fruit to pull off that tree, whereas we're still plucking the low-hanging fruit here. There's a lot more we can do to keep reducing the cost. And so if I can very quickly say a little bit more about one thing that worries me a little bit. There's been a little bit more research coming out last year and this year. Some of you might have seen this about how rising carbon dioxide in the atmosphere is actually changing the composition of plants that we're growing, right? So you get bigger, leafier plants, like the mass is there, but the protein content is reducing.
And less nutritious in
Less
general.
nutrition,
Yeah.
right? It's a little bit like if you overfeed someone with sugar, right? So the plants aren't getting a balanced diet. They're overfed on carbon, and you're not getting as much protein yields. And so we've seen that. Plus, so you're feeding that to animals, and for their own reasons, animal yields are also decreasing. So I get a little worried. Are we going to have a situation where it actually gets harder and more expensive to extract protein from these other sources? Well, you need to have a climate change proof, closed system way of converting plants into protein.
And also a different way of measuring it. We're measuring yield per acre. We should measure nutrition per acre, or per cow, or per bacteria, or whatever we're measuring it. So that's really what we should do. I was wondering also, we have, I think, from an investor here, how much money have you raised so far, and what is your current revenue?
We've raised about $62 million over the last 5 years, and we've made maybe like 100K. Yeah. No, that launch was not about making revenue, just to be very clear. I hesitate to even call it revenue. It's like we technically didn't lose as much as we thought we would because we made a little bit back. The revenue comes with the impact. And actually, it's important to me that we structure our business in such a way that we're only making money by having the impact we imagine having, right? I mean, that aligns incentives so that 20 years from now, when this company is, turned into a dragon that someone has to ride, these things develop their own sort of personality and their own will. And I want to make sure that, right, we're doing well by doing good. Right?
Do you think that the strategy of being a B2B, but then launching something like that into the B2C market, is that something that you are planned? Or, I mean, how do you think about the B2C, B2B market? Because I think most actors think B2B or B2C, but what I like with your concept is that you see potential in everything, of course.
Right. Yeah, I actually thought we'd get more of that kind of question when we did this launch. Like, hey guys, I thought you were B2B, why are you doing this? People seem to understand pretty quickly that you have to show a demo, you have to make it real for people, it has to be tangible, and in this case, tasteable. And there's no rule against kind of some of the products that get launched with this protein can be ours, actually. I mean, there's no reason you can't play in B2B and B2C if you're smart about resources and if you stay focused. And so for us, that focus means priority number one is always B2B, because that's where the impact is. And it's fun to play brand and do all this stuff, but that's not where the impact is, right? Like I said in the presentation, the big companies out there that are really driving the volumes, that's where the impact is.
Could it have an impact on feed?
That's a really good, is that from there?
No, that's mine.
Yeah, no, that's a good question. So actually, for sure, definitely.
Yeah.
That's a very good question.
If we're talking about impact, then feed.
Yeah, definitely.
If we're not going to have any cows, we don't need feed. But I mean, one way or the other, we're probably going to have cows.
Yeah.
So
Well, let's hope not. I mean, there will, but there's having cows, and then there's having a global industry built around factory farming them. So think about horses, right? Like, there are still horses.
we need grazing and
The average horse is probably way happier, and the average human working with horses is probably having a way more affluent experience than would have been the case 150 years ago. Animal feed, the reason that that's such a good question, and I'm kind of impressed to hear it, is not for the kind of obvious reason you might imagine, like fewer cows, less feed. It's that there are components that we feed to animals that are made through fermentation today. Right? And so the companies out there that have a lot of this infrastructure, I mentioned citric acid and vitamin C and things like that, but actually a lot of these big fermentation tanks are actually used to make amino acids for animal feed because we have to supplement their feed with amino acids to help their protein yield so that we get more nutrition from animal products. And so now we have a situation where maybe you don't need as much as much lysine to go into cattle feed because that tank is being used to make the protein directly. It's true.
we have, I think also we have quite a few students here in the audience. and you studied biology, I know. What would you say to a student that is moving into the future of food, biology, engineer, or all of the above? Or what would you say as an advice if you're going to go into future of food, vertical farming, whatever?
Yeah. So I studied biology, kind of. I really did chemical and biological engineering. And I think the core of my advice would be, if it's not too late, I don't know how young people are here, engineering is actually really important, because there's a mindset of making something real and making sure something can scale. And you mentioned indoor farming. One of the things that I ask every founder I've met in that space is, like, do you have a path to being able to make protein indoors? Do you have a path to being able to make, like, every crop or the most impactful crops, or is it more an alternative way to make fancy leafy greens and fruits, right? And maybe I'm wrong, maybe this is old. They are nutritious too, but it feels like there's a cap to how much impact that can have. And you don't necessarily need to be primarily focused on impact. But I would say the core of my advice here is think about things from an engineering perspective and how can this become real and how real can it become? Not just storytelling. Like, we need things that are actually going to work. And so be very skeptical and ask what's actually happening here.
You're saying on that you're looking for partners that use domestic agriculture commodities to create high quality proteins. What kind of commodities are you looking for? And what could we here in the north provide you with to become a partner with you?
What a weirdly worded question that we asked. I'm sorry about that. No, what we mean by that is, like,
that's from your.
I know.
I know.
Yeah.
So I'm like, what does he really mean? So that's why I had to ask that.
Yeah. No, thank you. I appreciate that.
Does any commodity work?
Yeah. Eventually, yes, and that's part of the idea here. One of the things that I would like to see biology do more, and actually for the folks out there that are earlier in your career and can do this, it's great to be able to take things like sugar and turn them into protein. That's kind of what we're doing. What I want to see happen is closing that loop of the circular economy. How do we go from things that are at the end of their life cycle and turn them back into raw materials that can then go into these fermentation processes and things like that, right? So
like beer and bread.
Yeah. Oh, wow. Ooh, that was messy.
Like beer and bread, you can make bread out of beer, and you can make beer out of bread. So
kind of. Here's what I really mean. After you're done, after you throw it out, you compost it or something. That needs to then not just go into landfill or some inefficient compost process. That needs to go back into the value chain at the beginning somehow, right? And what I mean here is
like
that
insects can eat compost.
Yeah, that'd be a great example, right?
Or
except ideally it's more flexible, because I don't know. Well, I don't personally want to eat insects. I don't know how many.
No, but you give it as feed.
You give it as feed. Yeah. That's right. That's right. And so there's no reason that flora can't eat bugs, for example.
Flora could eat anything. I know that also you found this trichoderma that you found on Solomon Island. I don't understand how you find that.
Well researched.
Yeah. How do you find that?
So we didn't find it. What we did is
How did they find it?
Actually, this is a great point for us to cover briefly here. So the idea here on day one was, we have an idea that no one's doing that we think is really compelling and it could work. But we're going to have to stand on the shoulders of giants, right? So we're not going to assume that you can start from a lab-level strain of yeast or something and get it quickly to the point where it's a fully mature, scalable, robust organism. Someone out there is already making protein through fermentation. Let's talk to them. And the answer was the enzyme industry, right? So if you want to make cellulases or even amylases, so you take starches and turn them into sugar, that's through amylases. These are already made in huge fermentation processes. And so the organisms that do that enzyme production have been matured for 30, 40 years. And so we talked to those folks. It turns out no one's using yeast. Barely anyone's using bacteria. It's all about fungi. It's all about filamentous fungi called trichoderma and aspergillus, which are, none of the words I just said are like what you want to see on your food, unfortunately. So that, again, is on the no-no list. But we call them flora because really the fact that it's a fungus instead of bacteria or yeast, to me, isn't really the important detail anyway. It's that it's in a controlled tank. It's that you're feeding it kind of plants and getting the protein you want out of it. These characteristics are shared regardless of what organism it is. But you're right. This trichoderma somehow was discovered in World War II eating the tents or the canvas material because it was making so much enzyme. People said, what if I threw that in a tank and sold that enzyme? I don't know why but they did. Yeah.
One thing that I always, when you think everything from vertical farming to cellular-based meat to what you're doing, precision biology, I've been working with sustainability for 25 years. There's always a flip side. And I've been also working a lot with antimicrobial resistance. How do we, because a cow, we can copy it, it's just biology, but it's so many bacteria in there. There's so much going on in a cow. Is it something that we will lack?
That we lack?
That we will lack with using your kind of process?
I'm not sure I understand the question.
In a cow,
Yeah.
you're making milk protein.
Yeah.
You're copying that. You have so many things going on in a cow that's not going on in your lab. Is there something that you think that we will miss
Yeah.
or lack in doing our food like this?
Yeah, so
In the future, do we, if we only eat things that are controlled in labs and not on the fields, where you get the natural dirt or whatever, you always say that some dirt is good for the stomach. So basically, you have so many bacteria that you can't really control. And the processes, can you really control them?
Yeah. Okay. There's so many parts of that I want to answer. I just want to be aware that we did run out of time, but let me say a few things. So there is complexity in milk that we aren't making. We're just making the protein, right? So people talk about the complexity of the milk fat membrane. There's this globule membrane around milk fat. It's supposed to be very beneficial for your body and all this stuff. We destroy that in the dairy industry already. We homogenize the absolute crap out of milk, and that milk fat globule membrane is gone. We purify the protein out, and you just have this pure source of protein that's going into bread products and sauces and stuff. We're making that protein. And so from that lens, anything that pure milk protein is going into, we can do. But if you want all the complexity of a raw, unpasteurized, unhomogenized milk, we don't claim to be making that, and we can't make that. But I think the spirit of your question is a little bit more upstream of that. It's what's the biology in the cow itself, is the complexity we're missing there. And I will say, no, I don't think there is. Because so much of that biology is related to keeping that animal alive and keeping that animal able to go locate food and find a mate and live a full life that we're not letting it live anyway. Very little of that is actually related to making protein in the udder cells. And so that biology is actually very well understood and very easy to control effectively in a tank. Yeah.
Thank you.
Yeah.
We run out of time. Thank you, Ryan.